Hello everyone. Let's learn the third project of intelligent operation and maintenance of industrial robot systems, cognition of the mechanical structure and principle of industrial robots. This project consists of 6 tasks. In this class, we will learn Task 1, Mastering the Mechanical Structure of Industrial Robots, Part 1. Task description. Articulated robots have the advantages of flexible operation, high movement speed, and a large operating range, making them the most common form of industrial robots in the current industrial field. Students should master the 4 major parts of the mechanical structure of articulated industrial robots: base, arm, wrist, and end effector. The logical structure of this task is shown in Figure 3:1. Part 2. Learning of relevant knowledge. The mechanical structure of an articulated industrial robot includes 4 major parts: base, arm, wrist, and end effector. See Figure 3:2. End effector. The end effector, also known as the hand, is a device that industrial robots use to directly contact and operate with workpieces, tools, etc. It has the function of simulating human hand movements and is installed on the mechanical interface of the robot's wrist or arm. According to different uses and structures, it is divided into 3 categories: mechanical grippers, suction actuators, and special tools. Mechanical gripper. Mechanical grippers achieve object clamping through the opening and closing actions of the claws. According to different clamping methods, they are further divided into internal expanding grippers and external clamping grippers, as shown in Figure 3:3. Suction actuator. Suction actuators take materials by suction force. According to the different suction forces, they are divided into pneumatic suction type, working by the pressure difference between the pressure inside the suction cup and atmospheric pressure, and magnetic suction type, working by electromagnetic suction force. Suction actuators are suitable for objects with large planes, unable to be grabbed by single-hand contact, fragile objects, glass, magnetic disks, and tiny objects, difficult to be grabbed, and are especially applied to handling robots. Special tools. Special tools are devices required to complete a certain operation, such as welding torches needed for welding operations, as shown in Figure 3:4. Wrist. The wrist is a component connecting the hand and the arm used to adjust the orientation and posture of the end effector, determine the working position of the hand, and expand the movement range of the arm. Industrial robots generally need 6 degrees of freedom to make the hand reach the target position and be in the desired posture. To enable the hand to be in any spatial direction, the wrist is required to realize rotation around the 3 spatial coordinate axes, X, Y, and Z. That is, it has 3 degrees of freedom: flipping, pitching, and yawing, as shown in Figure 3:5. According to the number of degrees of freedom, it can be divided into single degree of freedom, wrist, 2 degree of freedom, wrist, and 3 degree of freedom, wrist. According to the driving method, it can be divided into direct, drive wrist, and remote transmission, wrist. Arm. The arm is a component connecting the body and the wrist of the industrial robot, which completes the main movement and supports the weight of the wrist. End effector and the workpiece. It is composed of the power joints and connecting rods of the manipulator. Various movements are usually realized by the driving mechanism and various transmission mechanisms, thereby changing the spatial positions of the wrist and the end effector to meet the operation requirements of the industrial robot. Generally, a robot arm has 3 degrees of freedom, namely the telescopic movement, left-right rotation, and lifting or pitching movement of the arm. The rotation and lifting movements of the arm are realized through the base column, and the lateral movement of the column is the lateral movement of the arm. Base. The base is a basic component of the industrial robot, which plays a supporting role and bears loads. It is divided into two types, fixed base and mobile base. Among them, the fixed base is directly connected to the ground foundation. The mobile base can move relative to the ground and is divided into fixed trajectory and non-fixed trajectory modes, and industrial robots mainly use fixed trajectory bases. Part 3. Task Summary. The mechanical structure of an industrial robot includes 4 major parts: end effector, wrist, arm, and base. The end effector is a device that industrial robots use to directly contact and operate with workpieces, tools, etc., and is divided into mechanical grippers, suction actuators, and special tools. The wrist is a component connecting the hand and the arm, used to adjust the orientation and posture of the end effector, determine the working position of the hand, and expand the movement range of the arm, with flipping, pitching, and yawing movements. The arm is a component connecting the body and the wrist, which completes the main movement and supports the weight of the wrist, end effector, and the workpiece, with telescopic left-right rotation and lifting or pitching movements of the arm. That is all for today's class. See you next time.